Hello, folks. We're looking at number 5 on the review. Car A starts from rest and accelerates uniformly at 3 meters per second. Car B starts from rest also 6 seconds later at the same point and accelerates at 8 meters per second. Or I'm sorry, is it 8? 5. And I'll draw my arrows getting bigger quicker because it's accelerating faster. And at some point, car B is going to overtake car A. And they want to know how long that's going to take. So, sounds like a job for a Vovat. So, we've got two objects, so we need really two Vovats here. And so, for car A, starting from rest. Don't know the final speed. I know you're accelerating car A at 3 meters per second. And I don't know how far it goes. And I don't know the time. In fact, I'm kind of trying to find that time, aren't I? So, a lot we don't know. Car B starts from rest, accelerates at 5 meters per second. So, don't know the distance, don't know the time, but we do know that these distances or displacements that they're traveling are the same. We could take advantage of that. And the other variable that we're interested in is time. So I want an equation that doesn't involve final velocity. Oh, you can't see up there. It's going to be d equals v naught t, but the initial velocity is 0, so we won't even worry about that term. 1/2 at squared. And we're going to write it for both of them. But keep in mind, those d's are equal. So are the times. So we could have played with times, although that gets tougher, actually. So for car A, d is going to be 1/2 3 times t squared. So d equals 1.5 t squared. We got to think about this time issue, because we actually do know a little bit more info here about time, so we got to think about that a little bit. When I do this for car B, it's going to be 1/2 the time for car B. This is the time for car A, for car A, for car A. It's 1/2 the time for car B squared, and the acceleration in there too. So we can say, okay, that's 1/2 of 5. Now, we need to think about this a little bit. This is starting 6 seconds later. Let's say it took, make up a number here, 40 seconds for car A to get there. How long did it take car B? 6 seconds later, so they were only traveling for 34 seconds. They have 6 seconds less of traveling. Whatever time car A has, which right now I've been calling time A, time B is going to be time A minus 6 seconds. Because they're waiting 6 seconds before they start. So I can say this is time A minus 6 seconds. Now the beauty, well, we can obviously put that as 2.5. Because they're traveling the exact same distance in this, I can set those two equal. So I can say this one, actually whichever side, doesn't really matter. And I'm just going to drop the A's just so I don't have to write so much. And so time here means time for car A. 2.5 So t equals time for car A. 2.5 t minus 6 squared. And looks like you're in quadratic land again. We got to FOIL this and then distribute that. So we're going to get 2.5. FOIL, yes, you learned it in math. You got to use it this year. 12t plus 36 and 1.5 t squared. So what are we going to get? 2.5 t squared minus 2.5 times 12. So that'll be 30 t. Yeah, 2.5 times 36 will be 36, 36 and 18. 72, 90? I better check my math on that one. 2.5 times 36. I don't want to go astray here. Hey, that was 90. And 2.5 times 12, that one I was pretty confident in. All right. It's not quite in standard form for solving a quadratic yet. Let's bring this over. That'll actually make this a little bit nicer. You're going to get 2.5 t squared minus 1.5 t squared. You're going to get t squared minus 30. T plus 90 equals 0. Now you can go solve that quadratic. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And you're plugging in and going from there. Negative b, so negative of negative 30 plus or minus 30 squared minus 4 times 1 times 90 all over 2 times 1. You're in business. Remember, what you get out of this is the time for car A. One of these probably leads to a negative solution, which we can throw out. And then you're good to go. I just quickly worked them out to see how they looked. Both actually come out positive in this case. And that leads to a question of what the heck are you going to do with those? So, this leads to a solution that doesn't work. Because remember, the time for car B is 6 seconds less than that. So remember, this is your time for car A, so subtract 6 from that. That's not a valid solution. From this, I can certainly subtract 6, and I get time for car B is going to be 20.6 seconds. And I know that's a little bit off on the answers. Oh, well, we got an answer of 21 in there. So rounding that, they had answers to the nearest second, so 21 works. And we're good. If it was a test question, I would probably say once you get it to the quadratic, you could leave it alone. And then maybe like extra 2 points if you solve it type of thing. If it was a test question. I just don't want you spending a lot of time doing quadratic formula on the test. So usually we don't ask that for you to solve that far.